Thank you. Beasley.
Yeah, it's always tough for me when I'm thinking of your last name.
Yeah.
I think of you all as like first name.
I know. I never know. I'm used to doing that, I guess.
That's still not. How's that how I say your last name? Heinzmann. Yeah, that was way off.
Yeah, nobody gets it right.
This is like, yeah.
This is a crazy concept.
Yeah, this is fucking cool.
We'll see.
This is a good one. They're all good, but some of these are like able to make money right away. This is one of them. Can we close that door? Oh wait, nobody steals your ID.
I know. It's important.
All right.
Ready?
When you are.
Alrighty. What's up going on, guys? I'm Bass Beasley, and I'm going to be running you through what I plan to do this semester. So obviously, I'm going to hopefully be tracking corn commodity trading using satellite NDVI analysis. So I'll kind of break that down a little bit for you guys. So the first kind of issue is how can we actually track trading? I'll get into a little bit more of what NDVI actually does and what it is. But here are kind of some main implications that could be used with what I'm planning on doing. So first of all, commodity traders can potentially use the model that I plan to make to kind of have more information with what they're doing professionally. Also, the U.S. government has major implications in setting corn prices, so they're very interested in data and information kind of in the same way. And then just in general, I'm going to go over kind of what NDVI does right now and then what I plan to actually do with it. So some main connections to the course, and then I have some pictures here for you guys at what the satellite imagery is actually seeing. So the limits of human versus machine vision. I know when I brought it up in class, Dr. Gleason talked about this a little bit, but farmers are already using this technology to get information on, like the health of their crops. And using this satellite data is much easier than, say, they're going out there and using like their own eyes themselves. That's about all they had in the past in their own experience. So this kind of gives them a leg up, and I want to use that and kind of bring it into the economic space. Additionally, color spaces and spectral information. So NDVI actually uses infrared and red light, and that kind of determines the health quality as seen here. So what is NDVI? At the top, I've included the actual formula that it uses. The values range from -1 to 1, and then you see the near infrared and the red light over there on the left. So yeah, it basically measures the light reflected back, and it'll give you an actual value. So the higher the number, the more healthy the crop is. So like I said, it's used to monitor crop health. Right now, it's just kind of used to detect drought, stress for farmers, give them an idea of maybe their irrigation systems, what they need to be doing. And a lot of this is done with drones or satellite imagery. Personally, my application, I'll be using NASA and Google Earth to actually use the NDVI technology, and then I'll come in and attempt to build a regression model to predict the actual corn yield, and then from there, I want to be able to predict pricing, hopefully. So my data pipeline. NASA Earth and Google Earth are kind of free options I have for actually using the NDVI technology with their satellites. And then I get the actual health values for the crop. Then I go into RStudio, which is more the economic side of things, and I want to build a regression model to actually predict the pricing. So that'll take some trial and error. There are ARIMA models, 2 SLS models, so I kind of have to see what best fits and then what other data I might want to bring in to make my model the most accurate. And then finally, for output, I want to be able to, as accurately as possible, predict corn price, and that's going to be through the NDVI health maps. So for the techniques I'll be using, spectral band analysis. So that's kind of talking about the light that's reflected back using the infrared and red reflectance. NDVI, that's going to allow me to do that from the satellite data. And then finally, the linear regression through RStudio kind of see what the relationship is like and build my regression in my model that way. So what has already kind of been done in this space? So this first study focused on just specifically yield using NDVI, so like the crop growth essentially. And they were able to, I guess this value here, roughly 5%. You want roughly 5% if you're running a regression model, and so that means it's pretty accurate. So it's able to effectively predict the yield, so that's a good starting point for me. And then this was similar. The last one was kind of interesting. It gave me the idea to maybe factor in temperature with my own model, things like weather. You know, there are a lot of different factors that I can include in my data set to make the regression more accurate and to have a more accurate model. So where does my project actually fit with things?
Keep going.
Okay. So as I said earlier, NDVI has already been established as an effective yield predictor, but
Keep going.
okay. So far, nobody's really done more with that information. You know, they're getting the yield data, but other than that, I kind of just want to bring it to another level and be able to use this technology, which is obviously so effective at graphing and tracking the actual crop health, and apply it to corn futures and hopefully the price movements. Additionally, a lot of the NDVI data that's out there is weekly or monthly data. If I could get daily data, it would hopefully make my model more accurate and more specific. And then, yeah, NDVI and a model tracking price haven't been done yet, so that's where I want to step in. Professional value. So obviously trying to get a master's, I got in for a business analytics program. Something like this kind of goes directly alongside that. You're dealing with data all the time. So that's a good start, but outside of that, there are many firms that look at commodity trading. The USDA and government agencies are big players in this space because they care not only about the health, but they deal with pricing. And then a lot of hedge funds in a similar way. Skills. I've never really used much satellite imaging. I mean, maybe looking at my house on Google Earth, but this kind of is a step up here. So I'm excited to see what data is really out there and what I can use for my model. And then RStudio, I had a couple classes last semester with this, but being able to use it more is interesting and probably a good skill to build. And yeah, time series data analysis goes hand in hand with that, so that's what I'll be doing in RStudio. As for my deliverable, I want to have a finished product with an R code that works, and we'll see what that looks like. It's going to take trial and error, like I said. I need to get the NDVI data, run my regression, and then I'll deal with kind of what I need to tweak from there. And then extendability. The first thing that came to my mind was looking at other crops as well. You know, if you get like the code in place, you can just change the data set for soy, wheat, whatever it may be, and do the same thing for different crops. And then it could be, you know, extendable into thesis, publication, project in the future. So my timeline. Initially, I need to actually get the data that I'm going to be using in my model. So right now, I'm looking at NASA Earth and Google Earth potentially for their satellite images. And then I might take a look at the FRED and see what data is there about corn pricing already. Then data analysis, I'm going to take this data and get it into RStudio. That'll probably be through an Excel document that I import into RStudio and see what results I get at first. From there, I need to probably tweak some things, but I'm going to try to run my regression in R and get the best outputs I can. And then finally, we'll have our write-up and presentation. So take what I've found in RStudio and make an official report. Risk. So the first risk that I found was when there's cloud coverage, NDVI really struggles because the light can't really reflect as well. So I found some alternative uses if that becomes a problem. There's like another type of NDVI that's not really using the satellite images, but if you took a drone and put it under the clouds, it would obviously be able to see. So there are a couple other options there if I need to do that. And then the correlation between the NDVI data that I get and like prices or any other data I might use, if it's not really correlated, that's not going to help my model, obviously. So that's why I thought maybe bringing in some other data might help. But again, it's going to be trial and error. But yeah, temperature, precipitation, stuff like that might help make my model more accurate. Thank you.
Bass, this is excellent, especially given that you are doing a lot of this stuff for the first time. I want to hear what everybody else has to say, and then I have some very specific things. While you were listening to other people, I want you to grab a piece of paper and a pen, because I'm going to give you some very specific feedback here.
Sure.
I want to hear from everybody else what they think.
Yeah, I never would have thought about like this is a very lucrative.
Yeah, this is what quants do, right?
It's also like like you try to think about like all these different alternative ways you can get like satellite imagery, like all these ways you can get the bird's eye view on everything using Google Earth and NASA. Like
Yeah.
it makes it so much.
Yeah, absolutely. Bob.
What kind of model would you consider?
Yeah, I mean, in like what I've done in the past with RStudio is like a 2SLS or REMA model. Those are like the two main ones we use. So I don't really know how to describe it honestly, but
It's a type of linear regression.
yeah, it's a linear regression. Just there are just kind of multiple ways to go about it.
Yeah. So I wanna bring in a few things here. So first of all, Javal's actually working on a USDA project right now, and I work with the USDA quite a bit. So there's a lot of data that we might be able to bring to this project
Yeah.
that you wouldn't normally have access to, including some like high performance computing clusters. If you're interested in working in an economic space with agricultural data, I actually have a pretty good pipeline for you to consider maybe some internships or even like the USDA employs a lot of economic quants like Craig with that's what Craig does. I'm talking to Javal here, so that's what Craig is to do this exact thing, right? So here are a couple things. We're actually working on a kind of similar project right now, and I want to go ahead and break down a couple things for you. So first of all, NDVI is one of 30 or 40 spectral indices that are often used to look at vegetation health. And typically when we're trying to solve for a problem like this, we will throw every single one of these spectral indices at it and just see which one works the best.
Right.
Right? And so I need you to do a little bit of literature review, and I can give you some sources about other types of spectral indices.
Sure.
NDVI Red Edge, the Chlorophyll Index, CIG, and these are really simple band maps. It's no more complicated than what NDVI is. You're taking some bands, subtracting them from others, and then
Yeah.
trying to get like your end spectral indices.
Yeah.
Jackson, you might be doing something kind of similar, but it just won't be for vegetation health. So that's the first thing. We need to look at a lot of different spectral indices, not just NDVI.
Sure.
And I can help you prepare scripts. I can help you basically with all the coding on this. That's what, in a lot of our projects, that's what my role is going to be.
Yeah.
You explain what you want, and then I'm like, okay, let's spend an hour and just crush it, write it right now. Now you have the script, go put it on my Colab, okay?
Right.
The second thing, you talk about meteorological data. I think this is incredibly important because ideally, when we think about this, we think about like hypothesis testing, whether it's in economics or physics or computer science. And yeah, probably weather has something to do with whether the plants are healthy or not.
Right.
So NASA's POWER data set is worldwide coverage. It's a little coarse spatially. It's not going to get you down to like 10 meters, 100 meters, the way that Landsat will, but it will give you a ton of dimensions of weather data. And you can feed that
Use
into your
that.
model.
Right.
So NASA POWER. The next thing is that one of the things that you kind of gloss over is how do we know where the
Right.
There's a spatial dimension to this where we have to know where these cornfields are. That way we can start to study how the NDVI is changing, right? So we need to do a little work. The USDA has a lot of data sets on where corn farmers are, but we basically need to constrain our analysis to those places where we know there's corn,
Yeah,
right?
yeah.
And once you figure out that kind of processing pipeline, you can do it on soybeans, you can do it on rice, you can
Right.
do it on sorghum, you can do it on cacao, you can do it on salmon berries, right? So I think that, yeah, there is a GIS or spatial dimension because right now you don't know where the corn is, right? And that's probably something that we'll be able to get.
Yeah.
The last thing is that you say that part of the problem is that there might be cloud cover and the satellites can't penetrate. Absolutely. You're absolutely right. The USDA has a ton of data sets where they have basically crowdsourced a bunch of under cloud cover ways of getting it. So some
Right.
farmers own airplanes and they go fly this and the
Yeah.
USDA pays for part of it and then they
Right.
keep the data. Same thing with drones. So there's one of the things we could think about is whether satellite-based NDVI is going to be more useful or less useful than drone and airborne aircraft systems. I think that's something that we can talk with my USDA colleagues and see what data is available for you.
Right.
Finally, all of this makes total sense. The part that and it's very close to some of the consulting that I work on, so I'm very comfortable guiding you through this process. What I am struggling to understand here is how we're going to create actionable data for commodities trading. Does that make sense?
Yes.
And I think you are too.
Yeah.
And so I think that maybe just scoping it to, ideally we could get to a place where we could do this. Are you a junior?
I'm a senior.
You're senior. Okay.
Well, I'm a junior, but this is my last semester.
Okay.
So.
I was gonna say, because we could pick this
Yeah,
up with
right.
an internship with the USDA, no problem. I think that maybe for 6 weeks left in class, we want to move towards a commodities place, and certainly when you're interviewing at different firms or in grad
Yeah.
school, you're going to frame it that way. But there's a whole nother place about how we make this actionable that I think is bigger than what we can accomplish in 6 weeks.
Yeah,
Does that make sense?
it does.
But you're still going to frame that. When you sit in and you have that interview for that quant job you want, you're going to talk about making a commodities-based system,
Right.
But I am, like, right now we need to see if it works. And if you can, first of all, predict health with this combination of meteorological and NDVI. And if that works, then it should be relatively easy to go back and then see how that correlates with stock prices. And if there is a correlation, well, that's your money maker,
Right.
right? Final thing, and this is not holding this against you at all because we haven't learned it, but I need you basically, you guys like to use the phrase lock in. I need you to lock in the next like 3 weeks when we come back. Because we're gonna learn what a neural network is, and then we're gonna learn something, a technique in a giant family of like random forests, Markov chains, and basically what this is instead of doing one linear regression, we might do 10,000.
Yeah.
And we're changing a bunch of variables, and then we'll keep the one that works the best. And you get this kind of decision tree thing, and we circle the one that performs the best. It's kind of similar to like the K holdout things we talked about with shuffling a data set, but I think that typically we try to solve these problems with random fields. And we're going to cover that, and you just need to be like, we have these points where it's okay if you're like there, but your brain isn't as on, but like for some of us, there are going to be very specific points after spring break where you just need to be like doing all the reading, asking all the notes, reading all the supplementary articles that I give you. And when we get to random forests, and we're doing a whole day on just indices because spectroscopy or the physics of light spectrum-based approaches, we're seeing those in this project, we're going to see them with Jackson's project, and so we're going to spend an entire day just talking about that. Does that make sense?
Yeah.
Excellent work. I mean,
Thank you.
yeah, this is definitely an A. I just have to figure out if it's 100 or a 97 or a 98. That's very good.
Thank you.
This is cool to see. You still have the microphone on?
Yes.
So you can give that to Ashford. That's pretty cool, huh?
Yeah.
Yeah. We got a lot of. This is what I was hoping to see is that you guys are taking these and like.